everyone, my name is Shaline Lavinia with metric number 164182 from School of Physics, majoring in Medical Physics, and I'm the scriptwriter for this video.
Assalamualaikum and hi everyone, my name is Mahirah Qistina Binti Mashrizam. I'm a first year student with metric number 164476 from School of Physics, majoring in Biophysics, and I am the presenter of this video.
Hi everyone, my name is Sashmitha Sukumaran and my metric number is 164435. I'm from School of Physics and I'm majoring in Medical Physics. I'm the editor of this assignment. Thank you.
Previous video? If yes, can you guess what is it about? Well, if you don't know what it is, don't worry, for I am here to explain it. Without further ado, let's jump straight into the content. To begin, what you saw in the video is called the airport security scanning. Now, before we jump into the process of this security scanning, let's learn about some radiation facts that uses the principle of radiation for airport security scanners. Firstly, airport security system use metal detectors, basket X-ray machines, millimeter wave scanners, and cabinet X-ray machines to keep people safe while traveling. Some security devices use ionizing radiation to scan luggage, and safety measures are in place to make sure it does not expose workers and travelers to high levels of ionizing radiation. Some devices, such as metal detectors, uses non-ionizing radiation to scan travelers to make sure they are not carrying hidden items that can be prohibited for air travel. Now, let's talk about the radiation and airport security scanning. Keeping public places, such as airports, safe is a big job. Transportation Security Administration (TSA) screeners at airports check passengers and personal items for dangerous items such as weapons, chemicals, and liquids that are not allowed as carry-on items. They use screening equipment such as metal detectors, millimeter wave machines, basket X-ray, and cabinet X-ray machines. These devices also detect items that may be hidden. The various types of screening equipment used at airports today each have a different screening purpose. Guidelines are in place for using the equipment in order to keep you safe. Moving on, let me explain the process of using the non-ionizing radiation scanning equipment. Metal detectors use magnetic field to help identify metal objects. Magnetic fields are produced by the flow of current through wires or electrical devices. Metal detectors create a magnetic field by using a brief pulse of electrical current. The magnetic field will be reflected back to the machine if there are any metal objects present, such as a watch or a belt buckle. The return signal is detected by the machine and a beeping noise is produced to alert the TSA agent. The metal detectors ignore very small amounts of metal, like the button on your jeans or a small earring. Some equipment uses non-ionizing radiation. Non-ionizing radiation has enough energy to move atoms in a molecule around or cause them to vibrate, but not enough to remove electrons from atoms. In airports, metal detectors and millimeter wave machines use low energy and non-ionizing radiation to send energy across scanned surfaces. The energy that bounces back from the scanned surface will show the objects that are present, or it can generate an image that TSA agents can use to show items that may need more investigation. Interesting, right? Now, let's talk about how millimeter wave machines work, which is a whole body imaging device. Millimeter wave machines uses non-ionizing radio frequency waves to detect threats. The machine bounces off the body and back to the machine. Millimeter wave machines are important pieces of airport security equipment because they can show hidden threats such as guns and knives. If there are no weapons or other potential threats, when someone is scanned, the screen turns green and shows okay. If an object is detected, it will appear on the screen along with a generic body outline to show the location. Not everything that shows up in the scan is an actual object or threat. While millimeter wave machine uses non-ionizing radiation, there are other equipment that uses ionizing radiation. Ionizing radiation has so much energy it can knock electrons out of atoms, a process known as ionization. Airports use ionizing are used to detect threats such as weapons or explosives that a person could be carrying under their clothing. Backscatter machines use very low energy X-rays that are reflected back to the machine itself. Generally, the amount of radiation received from a backscatter machine equals the amount of cosmic radiation received during the 2 minutes of flight, and the risk of health is very, very low. In the case of cabinet X-ray system used to screen luggage and carry-on items, the thick walls of the enclosed cabinet and lid curtains at the entry and exit points of the cabinet keep radiation from escaping. The machines must meet strict standards about how much radiation can escape the cabinet. The machines must also have locks, warning lights, and warning labels to keep it safe. Now, with all of this knowledge, it is vital for us to know the risk of this radiation to keep us safe. Apple screening helps keep travelers safe by identifying hidden weapons and other hazards that are not approved for safe airline travel. The risk of health effects from backscatter X-ray systems and millimeter wave machines is very, very low. However, if you are worried about X-ray or millimeter screening, you are not required to walk through these machines. You can ask for a pat-down search instead.